By now you have probably seen this unit that I have sitting here on the bench in other YouTubers videos as well as my own, because I've used this quite a bit. It's an inexpensive WEP 858D Plus hot air station, and they're not the greatest or anything like that. They are pretty cheap, but they do the job for the most part. They might have their own little quirks here and there, and I have had to fix a few little things of this one. So they're not exactly, you know, like the most perfect thing. You know, it'd be nicer to have something better than this, but for the price and, you know, what it does the job for the most part. One of the little quirks that it has, though, is that the base here, where the holder is, has two magnets, one on each of these sides, and you can kind of tell here if I put the screwdriver up close, you see that it sticks there, and then if I go to the other side, it sticks there. So what it does is when you put it on the base, the fan is supposed to continue running, but it shuts off the heating element, and it'll just continue running until it reaches 100°C, and then it just turns off completely again. Well, the thing is, if you have the handle or the handpiece kind of sitting like that, where the magnets are sort of like in between, a lot of times they won't activate that reed switch, and this thing will just continue running, and then, you know, you kind of have to turn it until you see that it, you know, shuts off or whatever. And that's the whole reason why I marked it there, so that way I can just quickly, you know, like turn it or set it where, you know, I know that the magnets are going to be activating the reed switch. Well, the thing about that is that to shut it off, you need a magnet. And sometimes when I have this mounted on this lamp base that I modified, I'll, you know, clamp it down to this bracket here. You know, I use this more when I'm, say, like replacing a BGA or doing something where, you know, I want to keep like a certain part of the board like warm. So what I'll have to do is I'll have to get a magnet. I usually put this like closer here to the metal, and I'll just stick a magnet here, and then that gets it to shut off. Well, I wanted to do a modification, and I was just going to do this on my own, but then I figured, hey, they might actually want to see, you know, what I did or whatever. So that's the whole reason why I'm sort of documenting this. And I kind of decided to do this after seeing a Dave Jones video where they had one of these that I guess like melted down. I wanted to make this modification for a while. I just haven't gotten around to it, but I figured, you know what? I think it's time I get around to doing that. So what I want to do is I want to add a switch so that I can have some manual control over, you know, when this thing shuts off without having to use a magnet of any sort, or without having to resort to making sure that this thing is in the right position or anything like that. That way I can say, you know, like leave this here, hit a switch. I can, you know, shut it off when I want to without having to use magnets. So what I was originally thinking of doing is maybe putting like a little switch up here at the top. The problem is there's like no room back there. So I kind of moved over into like this area of the handpiece, and there's a little bit more room in that area, and I was going to use a small switch like this one, like a little slide switch, but there's really not that much room there either. The easiest thing to do would be to put one on the base itself, and when I took this cover off just to check to see if there was enough room there, turns out there is. This whole area here is empty. So I found me a switch that looks pretty much identical to that one that I'm going to install in that spot there. So when I want to turn this thing off and I have it sitting on, you know, like the holder, I can just do it from there without having to shut the entire thing off. Because, you know, if you shut the entire thing off while this thing is still hot, that fan is not going to be able to cool it. And you don't really want that, because then, you know, it might start melting the plastic or something. So you want the fan to run just until it's cool enough, you know, for the unit to stop running it. So one of the things I need to do here first is figure out which wires from the handpiece actually go down to the base. And if we take a look inside, we see that the reed switch is right there, the magnetic reed switch. It's got two red wires that run towards the back, and they're attached to this board. This board is normally screwed down to that side of the case, but I took the screws off there because we need to see which wires actually go to the board here. And this board doesn't have any other components on it. It's basically just like for interconnecting the cables coming from the base to everything up here, like the heating element, the thermocouple, and all that stuff. One other problem that I had with this before, and actually it happened while I was doing one of the videos, is I was replacing a chip on a TCOM board on a TV, and it was, even though I had the temperature set to what should have, you know, heated it up enough to remove the chip, it was going nowhere. Well, what happened was that these wires, that blue and red one right there, are coming from the thermocouple from the heating element. They were attached directly to this board and like soldered. The thing was that solder doesn't really stick to that wire. So basically what happened was, we've got the board, we've got like, you know, like this little solder like sitting on the copper. The wire comes in through the bottom like that, but because it doesn't really stick to the wire very well, the solder eventually kind of cracked and created a cold solder joint. So I wasn't getting good contact between the thermocouple and the board here, and so the unit wasn't able to, you know, see what was going on. And I think because of that, what it would do is, instead of continuously heating, it actually would shut off the heat, since it couldn't sense anything on the thermocouple. And so yeah, I figured that out after I took this apart. And so what I did instead is I got a couple of small, it was just like a bare metal, but two small bare metal butt connectors, and I crimped the like one side to the thermocouple wires, and on the other side I just put two regular sets of just regular stranded wire that I could easily solder to the board over here. And then I just coated them with, or I put some heat shrink over them, you know, shrunk all that so that I'm not risking, you know, these touching or anything inside of that. So that helped a lot. I have not had any problems with that ever since. So that was like the first little modification I've sort of done to this thing. It may have thrown off the calibration a bit, you know, by doing that. But for most of the stuff I do, I don't require like any, you know, really specific temperature or anything like that. And if I am doing anything that requires, you know, a little bit more control, I'll usually use an external thermocouple on the multimeter, and then that way I can actually monitor what's coming out of the thing. If I really wanted to, I could probably take that same thermocouple, stick it into here, you know, and run it and see what this thing is supposedly set at and what I'm actually getting out of the thing. And then it's got the little, oops, can't even see it. There's a little calibration pot behind this little rubber plug that's sitting right there on the faceplate. So I could do that, but I haven't really bothered because, like I said, I just kind of set it like at a rough temperature of what I need, and, you know, I'll do whatever I need to do. Now that we've gone on a tangent, so we've got the two red wires coming into this board, and these are running straight through, so we can see that they are attached to this blue and this yellow wire here, and those are the ones that are going back to the base unit. So if I flip this over, we see that the red ones, which are these two right there, are just running straight through. So on the base unit, I'll have to tap into wherever the blue and the yellow wire are going to, and that way I can control the heating element, you know, directly from the base if I want it to shut off and cool down. I want to find out first if this read switch is normally closed or normally open type, because I'm not entirely sure. I would assume it's normally open, because for the most part they usually are. The normally closed ones do exist. I know that there are some that are like a single pole double throw, so they'll have like two wires on one end and a single wire on the other end, and then, you know, it'll be like just like a switch, but it's magnetic. And let's see what this says here. If we just, let's see, if we get a beep, then we know that it's normally closed, and we're getting nothing. So I'm going to take this magnet just to double check. I'm going to touch it, or right here. Yep, there you go. When I get the magnet close enough, it makes the read close, and so that means that, yeah, it's normally open. So that kind of creates a little bit of a problem, because the switch that I have would be open in this position, and as you can see, I only have two terminals on this switch. It's not a big deal. So that's where the switch is off, you know, we get no continuity. When we turn the switch on, then we get continuity. The thing is, though, that I would want the on to signify, you know, that I have the heating element on, and off to signify that I have the heating element off. And this is not going to work, because what we want to happen is, when we want the heating element to be off, we need these two to be making contact. That's not how it's set up. But the cool thing about these switches is that you can actually, on not a lot of them, I'm not going to say all of them, because some, you know, they'll have like a little light inside or whatever, like an indicator, so that when it's on or off, it'll, you know, indicate. whether it's on or off. But on this one here, I think I should be able to flip this around, the actual rocker, so that when I want the unit to be off, I can flip it over to this side and I will have continuity between the switch. And when I want it to be on, then I hit the switch to on and it'll open up the contact. So let me show you real quick what we're going to do about that. So I have a sort of a dull blade here, and so that way I don't risk cutting myself so much or anything. I'm going to stick it in between the rocker and the body of the switch, and I'm just going to gently pry until I can, you see how the switch is like partially separated right there from the body. So there's a little peg that's built onto the rocker that sticks out through these holes on each side of the switch body, and that's basically where the rocker pivots. And now I gotta pop the other side out. Actually, it's probably easier if I just finish popping this side out first. Just gotta make sure I don't lose the thing because these are sort of spring loaded, and this side is mostly out. Alright, so this is just about to pop out. It turns out I only needed to do it on one side. On some of these you kind of have to do both, like work them both at the same time. This one I got away with just popping out the one side. So it's almost there. And there it is. So now I've got the rocker out, and inside what these have is they'll have this spring loaded, it's sort of like a cap, it's sort of like a domed cap, and there's a spring inside of that cylindrical protrusion there from the middle of the rocker. And what they do is it takes this piece here and it just like rocks it back and forth. This one's only got like a single contact on it because it's a single throw switch, so that stays in there. And as we can see, it's got sort of like it's got a curved shape, so that metal cup just kind of like rocks back and forth to on and off. So I'm going to leave that in there like that, and the only thing I'm going to do is rotate the rocker. So now when we want it to be off and it goes in this direction, it's kind of hard to, it's going to go in this direction. It's going to make that sort of like pivoting plate there make contact between the center and that terminal, and then that way we can have the heating element, you know, shut off. And when we want it to be on, the rocker will push in that direction and it'll cause the switch to open. So now pop that back in like that, and now my switch will work as intended. So when we want the heating element to be off, we hit it to the off position, and now if we measure it, we will have continuity between the two terminals, just like that. And then we want it to be on, now the switch is open. So that'll work. So I'm just going to set this aside. Got that ready. I can actually put this handle back together now because I really just needed to know, you know, which wires go to here. Also, make sure you don't break the wires to the fan. They're pretty fragile. And now I'm going to have to solder this back on. Another sort of modification that I'm going to do to this, and not because I want to, but mostly because it's broken. I dropped the handpiece and it smacked the bench really hard one time, and it, as you can see, it's broken. So I'm just going to cut it from there, and so I'm just going to have this ring, because you still need this ring, it's threaded, that holds the end of the handpiece shut. And even though, you know, it's good to have it just as a sort of a shield, I really don't handle this thing like from the front very much, and sometimes this does interfere a little bit with things I'm trying to do. So I'm just going to, yeah, cut that off and make it into more of just like a nut for the end of the handpiece. Almost done. Alright, that's better. Okay, so let's move on to the actual thing we want to work on. So in here, that is the connector that the blue and yellow lines come into. So So what I'll probably end up doing is soldering this somewhere on the board. I'm not sure exactly, you know, like where. I don't know if I want to do it like right to the opposite side of that. Maybe. But yeah, basically that's what I need to do. I just need to put the switch between those two wires. Alright, that was a little more work than I thought it was going to be. I wanted to get everything off of the faceplate so that I could transfer the cutout of this switch and put the other one kind of like in line here, you know, just so it doesn't look all janky, like offset or or like, you know, off to the side or whatever, just so it looks a little cleaner. And now I can remove this switch. I actually had to desolder this wire from the other wire that goes to the transformer, and then it just had like some heat shrink on it, so you know, I can redo that. That's not a big deal. The other one, I just popped the terminal out of the connector. So alright, so the power switch is out, and the new switch is, I mean, it's like pretty much identical to that, so I could even, you know, replace that with that. So all I'm going to do is put some masking tape over on this side, and then just get a ruler and just mark it out, and, you know, just make the width like about the same. And then after I do that and I have where my hole's gonna go, I'm going to drill a hole there big enough to fit the head of this nipper, and then I can just kind of like nip it all out nice and square, and this switch should fit nicely. Okay, so that's where my new hole is going to go. I just kind of cut it out after I measured everything. That way I don't, when I drill into it, like the drill bit doesn't grab the tape and tear everything. So, and then when I start nipping all the metal out, that way I know where I'm supposed to stop, like right around the edge. Alright, so I've got my hole drilled, and it's big enough to fit the head of the nippers in, just like that. So now what I do is I align the very edge right there on that corner, kind of like where I want to go, and then just squeeze down, and as you can see, it cut out a little flat section. So I'm just gonna do that all around until I get to the dimensions I want. Alright, so now I got my cutout there. It's a little rough, but I can take a file and just kind of smooth it out a bit. I have a little bit of material right there, it looks like, so I can actually nip that as long as I don't go too deep. It's like that. Mostly got it. So yeah, I'm just going to probably just clean it up with a file now. And I think that looks pretty alright. Okay, let's see how this fits. Seems a little tighter over on this end over here. Yeah, I'm gonna have to file that down a little bit right there. Okay, round two. There we go. Sitting flat. Not going to wiggle around at all. Now let's put this one in just so we can see how it looks. Make sure that it's not like way off or anything. There we go. I was hoping to find a more mechanical way of securing these wires, but I mean, there's really nothing else on this board that I could have done. Like, I can't go through this hole because that's one of the mounting holes, so I decided to use hot glue, which is not really my preferred thing, but I mean, for this it'll probably be more than okay. So that's just going to come around like up like that, and then I crimped on a couple of terminals to the end of the wires there, and that's going to go into the switch. But I don't really want these to be fully exposed like this, so I'm going to heat shrink to each terminal like that. And then that way they are nice and covered. Of course, normally I use the hot air station itself to heat shrink stuff like this, but since that's not available at the moment, I'm just going to have to use a torch. Just need to be gentle, not to actually burn the stuff, because this one gets hot. And there we go. So now it's just a matter of reattaching everything. Alright, how's that? Oops, popped it out. There we go. It's not completely back together yet. Oops, gotta make sure I don't short anything out back here. But let's see if it's gonna work. I mean, it should. It's not like it's anything super complicated, unless I manage to bork something else in the process. So we're gonna turn it on. Let's set it to 150 just so we have somewhere to work. Whatever. 149 is fine. So once I take this off the holder, it should turn on. Oh, I have it on off. Okay, that's working so far. So if I turn this on, it should come on. Yep, there it is. So yeah, it's gonna reach temperature. Now if I put this on here, it should start cooling off, and yep, it's working. Okay, now when I pull this off, it should turn on. Okay, now if I hit the switch here to turn it off, it should start cooling down. And yep. So, yep, working as intended. So that's gonna do it for that one. I'm actually pretty happy with how that turned out. I think I like having the switch here better than what my original idea was of having it on the handpiece itself. I think it, well, it's a lot more accessible there, and that prevents from, having a, or accidentally bumping it here and, having it affect whatever it is I'm doing. Because this is, going to be sitting kind of out of the way for the most part anyway. So, yeah, there we go. It's working pretty well. And now my bench is a mess again. I've got little shards all over the place. So, it's like an ongoing battle with trying to keep this thing clean here. So, well, as always, thanks for watching once again, and I'll see you guys around the bench.